So, good evening. Welcome to the third night of our Graze Debate 2. For those that have stuck with us, we've heard from the excellent Colleen Humphrey, James Drummond, and Tom Stobbart showcasing their practice of rotational grazing very well on Monday. Last night, you will have heard from myself and my colleague Lorna Galloway, excellently chaired by Jack Munro, who's behind the scenes tonight. And we gave a bit more of the theory of rotational grazing, a framework, the infrastructure, and how feed budgeting can fine-tune your business. Tonight, I am really excited to bring to you some researchers that are really giving some good, real on-the-ground science relevant to your grazing businesses. So without further ado, I am going to, just to kick off to the next slide, sorry. Just a couple of things for those new to this. There's two ways in which you can interact with us tonight. If you have a question you'd like to direct to one of the speakers, please put that in the Q&A in the questions box, and then it won't get lost. And then if you just want to chat with us, we'd love to hear from you, where you are, and just your opinions on stuff that we're discussing. And please put that in the chat. That would be fantastic. So our first speaker of this evening is Aurélie Aubrey. She is from the Agri-Food and Bioscience Institute in Belfast. And she is going to present on sheep paddock grazing trials. Her research focuses on the sustainability of sheep production systems, so by improving efficiency, reducing greenhouse gas emissions, and minimising environmental impact. So I will hand over to you, Aurélie. Thank you.
Okay, thank you very much, Poppy. Thank you, everybody. So yes, my name is Aurélie. I'm based at AFB, and I'm based at the experimental livestock farm, which we have at Hillsborough, which is near Belfast. So you can see a picture of some of our buildings here on the front slide. And there's also some of our ewes and lambs that we've been using as part of our grazing trials. We have a flock of about 300 ewes that we can use at AFB. I wish to acknowledge my co-author, Tara Meek, because most of the work that I'm going to present tonight is part of the work that she's been doing as part of her PhD. So the research I'm going to present today is part of a project called Lamb from Grass. It's a 3-year project funded by DERA and AgResearch, our levy board. And as I mentioned, there's also a PhD study as well as part of this, which is also funded by DERA. The main focus of this project is to run some grazing trials to investigate the effect of different strategies, grazing strategies, not only on the animal performance, but also on the performance of the grass. We've been doing this using our own sheep flock, or part of it, and we've also been working with 5 commercial sheep farms across Northern Ireland. And the main objectives of that overall project, there were more than one. It's not only to evaluate a 4 and a rotational grazing system, but we also, by working with those farmers, we aim to provide an improved understanding of the variability in grass growth, production, and quality. And this is helped by the fact that those farms we've been working with are part of the Grass Check program, which maybe some of you have heard. I mentioned a bit of that at the end of my talk tonight. Another objective was for us to help us to identify realistic targets for lowland sheep systems, in particular in terms of grass yields. Both with the AFB flock and on farm, we've been able to evaluate the effect of a 4 and versus an 8 paddock rotational grazing system. And lastly, on these commercial farms, they've also used 3 different types of kind of novel breed types. I'll mention that briefly as well, to see whether these breeds can respond differently to similar grazing systems. So there's a map here of Northern Ireland where you can see, the green dots represent the farm we're working with. So just as a means of introduction, we all know that grass, represent a great value. You might have covered some of that as part of, the current series of webinars or other events. But very briefly, this is because grass, especially for sheep system, can provide most of the energy requirements for those animals. and it's also our cheapest feed source relative to silage and concentrates in particular. It's particularly relevant for us in Northern Ireland because we're able to produce lamb from almost entirely grass-based system. So the key really here is to make sure and find ways for us to have high quality grass that we can obtain, and in order to achieve high levels of lamb performance and output. So grass utilization, grass quality, is important, but the way it is utilized by sheep is also key. We know that grass utilization influences the profitability of grass-based livestock system. It's not only a good thing to try and produce more grass, but if we do so, then we need to make sure that it is actually utilized by the sheep at the end of the day. And the problem is that we currently know that there are clear inefficiencies in both the level and the quality of herbage utilized per hectare in most of our systems. In the past few years, as part of a sustainable agricultural land management strategy in Northern Ireland that we've been developing, we estimated that most sheep and beef farm produced only just above 4 tons of dry matter per hectare, which is well below, what can be achieved on grasslands and on other systems, in particular dairy farms. We know, based on past research, that rotational grazing can deliver higher levels of animal and gross performance compared to set stocking, and I believe that some of that is going to be covered a bit later on this evening. But for the purpose of our particular work program, the main question for us was to see whether, can we investigate grazing system, and can we try and identify what would be the optimal rotational grazing system for sheep, and in particular, an optimal number of grazing paddocks. So I'm going to first present the work we've done using our FB sheep flock at Hillsborough. So we replicated the study across 2 consecutive seasons, 2018 and 19. We looked at 2 rotational grazing systems, a 4 and an 8 paddock system. We did that on a relatively small scale, probably much smaller than maybe what Catherine will cover later on, but you can see an aerial picture here from a drone of the setup we had. And basically in our 2 systems, we had the same area, so 1.6 hectares each. We had a group of 20 ewes that we rotated either among 4 paddocks or among 8 paddocks. And we used a balanced group of Suffolk and Texel sired lambs to do this. And you have a small picture here at the bottom of the type of electric fences that we used to do that. Our flock typically lamb from mid-March to mid-April, and right after lambing, they were turned out to pasture. Our management decisions, we had kind of targets in terms of pre-grazing herbage mass. You can see here on the table, post-grazing sward height, pre-weaning, which was 4 centimeters, and after weaning, we started with the lambs, which we took out of the pasture at about when reaching 5 to 6 centimeters, and they were followed by the ewes. Lamb growth rates were recorded from birth to slaughter, and as part of the PhD study, we were able to fit some behavior collars as well on a subset of the ewes, 20 in totals, and their lambs in both grazing systems. All lambs were weaned on average at 14 weeks of age. As I mentioned, we had a leader-follower grazing system post-weaning, and all the lambs were drafted for slaughter at the same target slaughter weight, with the aim to produce carcass weight of 20 to 21 kilos. And the data was well balanced, so we were able to run the statistical analysis, which I'm going to summarize now. So first of all, in terms of animal performance, there was no impact on ewe performance when comparing the 2 systems, both in terms of body condition score and changes in live weight. The table here represents average daily gain for different periods for the 4 paddock, the 8 paddock, and in the last column, it shows whether the difference is significant or not. And as you can see, then there was no difference in lamb performance up to 6 weeks of age, but after that, we started to see differences. And overall here, basically, our average daily gain was higher for the lambs that were grazing the 4 paddock compared to the 8 paddock system. And it was quite a big difference, and it resulted in higher weaning weights for the lambs on the 4 paddock system. You can see below, just below almost 3 kilos difference between the two systems. So in terms of carcass traits, this is, the summary of the data we found as well, again, comparing the 4 and the 8 paddock system. We had, sorry, I have to move my screen because I see the videos there. Here we go. So in terms of, live weight gain, so the difference in live weight gain carried through up to slaughter, so we still had difference. And that led to the fact that the lambs from the 4 paddock system were finished earlier, on average, more than 30 days earlier than those on the 8 paddock system. So it's quite a big difference. The carcass weight didn't change because, by design, we had the same target slaughter weight, which is good. And then none of the other carcass traits were, they were all the same. They were not different. Carcass conformation, fat score, and kill out percentage. In terms of grassland performance, now this table, summarizes what we obtain for the two systems. We, on average, each paddock from the 4 paddock system were grazed once more in the season, but the average pre and post grazing heights were the same, which is good to see as well. We were able to properly, manage the system according to our targets. But interestingly here, you can see in the last row of that table that on the 8 paddock system, grass utilization was better, 84 compared to 72%. So the sheep utilized the grass available to them better when they were on the 8 paddock than the 4 paddock system. When trying to summarize then in that slide the grass production and the quality across the two systems, as I mentioned in the table before, we had 1 additional grazing per season on the 4 paddock system, but the grass yield was better on the 8 paddock system. So you can see it on the histogram here. So it's the ton of dry matter produced per hectare in a particular year. So we have for 2018 and 2019. In green, it's the 4 paddock, and in blue, it's the 8 paddock system. And you can see that on average in both years, we produced almost 1 ton extra grass from the 8 paddock system. So this really means that, that 8 paddock system to us provided opportunities for higher stocking rates or silage production, and that's what the farmers who implemented that as well found. I'll mention that in a second. In terms of grass quality, we couldn't see any difference, in all the typical parameters that we monitored throughout the year. So no difference in terms of quality, but a difference in terms of production. So that was for the detailed kind of study we've done at Hillsborough. And then, as I mentioned, we've also worked with farmers to do something a bit similar. So I'll have a few slides on that, and then I'll summarize it all. So we had 5 commercial sheep farms across Northern Ireland. There were kind of 3 components to the work that they were doing. One is that they were part of the Grass Check program. Secondly, they evaluated a similar 4 and 8 paddock system. And thirdly, the group of sheep they had was balanced, and they used 3 different kind of sheep breeds, which we hadn't really used before. And that enabled us then to try and see whether any of these breeds responded differently to a similar grazing system. But I won't cover that tonight because there's no time and it's not the focus anyway. But if any of you are interested, drop me a line and I can certainly give you more information on that. So in terms of the sheep farm, so here you can see there's 5 of them. The average paddock size was 1.2 hectares. There was 1 farm, the first one here, which had much higher paddock size because they were able to do the 4 and the 8 system using their whole flock. So which was quite interesting to do, to see if, this kind of system worked well as well on larger flocks. So two slides now, one on looking at the animal performance. So in terms of lamb growth, sorry, there's lots of lines, but it's just trying so that you can see it all in one go. So we have 5 different farms. We have the 4 and the 8 system. and 2 colors. The green is for the average daily gain at up to 8 weeks, and the blue it's average gain to 12 weeks. And what you can see from that, if you compare, the first set of 2 bars and the second set of 2 bars for each farm, is that it doesn't vary very much, except for maybe this farm here, where we also found that the live weight gain were higher on the 4 paddock system compared to the 8. And that translated as well to higher winning weight on that particular farm. And there was another farm as well where we picked that up as well in the statistical analysis. So as you can see, on average, an extra 2 kilo in terms of winning weight for the lambs that were on the 4 paddock compared to the ones that were on the 8 paddock system. So to conclude then, these kind of paddock grazing trials we've done both at Avby, Hillsborough and on farm, lamb performance was higher most of the time on the 4 system compared to the 8 paddock system. There was no effect on carcass traits and no significant effect on ewe performance either, but there was an average surplus of at least 1 ton extra produced from the 8 paddock system, which is no effect on average quality. So really that shows us as well that based on the overall yield that we obtained, which was above 8 ton dry matter per hectare, that there's a real potential for our sheep farms in Northern Ireland to increase their grass production, especially if using such rotation grazing systems. The work we've done here shows that by increasing the number of paddocks within a rotation system can result in higher levels of herbage production and utilization, but it may also result in reduced lamb performance. So that means that maybe the optimal number of paddock might be different depending on your farming system and depending on your flock size and your targets for slaughter. So before I finish, I wanted to give you just a couple of slides on maybe the feedback that we've obtained from the farmers who've been doing the work and working with us on that. Of course, at the start of the study, it was, we had to invest quite a bit of time and equipment in setting it all up. But once it was set up, all of them found that the paddock system was quite easy and pleasant to manage. The 8 paddock system in particular offered them, a great level of flexibility. And in that throughout the year, if there was a surplus of grass in particular, then they were able to either use it up by closing the paddock and producing silage if the paddocks were large enough, or we have another farm who had like a floating group of dry ewes that they used to use the additional amount of grass as well. So they appreciated that flexibility. Of course, to enable to address and deliver that work, they had to measure grass covers regularly every week on the 12 fields. This is time consuming, but they found it very useful to inform their grazing and grass management. The key thing here is that, record is key because you can't really manage what you cannot measure. So recording all that data is very useful. And to help with this, we've been using grass management software tools, which they also found very useful, especially, I might say, if it's done as part of a group so that you don't feel, all alone doing that. It's nice if you can do that. And I think most grass management software can allow you to do that, to join up with other people so that you can compare, your grass wedges and your data. So in our case, we were able to do that because they were part of the GrazeCheck program. So you might be familiar with GrazeCheck NI. We also have a GrazeCheck GB that has been recently established, so you can find some more information online. But very briefly, this is a long-term grass growth and quality monitoring project involving almost 50 dairy, beef and sheep farms over a range of systems. And what they need to do, they need to do the weekly grass cover on their grazing platform, send a sample of grass every 2 weeks for quality analysis, and they also need to record all their inputs in terms of fertilizer, for example, and animal performance as well. So if you, again, just there's more info that I can give if any of you are interested. And by using the grass and management software, we can realize the benefits of measuring record grass covers to better manage your rotation system. For example, here you might have seen, that's an example of a graph we see, which is a grass wedge. and you can use that to optimize grazing days on each paddock, identify the next paddock to be grazed, especially on the 8 paddock system. It might not always be the same one that you graze, in the same order. And it helps to identify grass surpluses as well. So that was greatly appreciated by the farmers that use the tools. And something else you can produce is, compare, for example, here, which is a total production for a number of fields, and it helps you to rank the fields and compare them against one another. And if one is really performing not very well compared to others, it might, mean that you need to maybe reseed that field or whatever if you realize that it hasn't performed very well in the grazing season. So this is my last slide now in terms of knowledge gaps and the kind of next step in our research program. We want to try and identify more strategies by looking at different paddock systems from turnout to slaughter. And we feel it might be that the optimal number of paddocks might vary across the season, especially when we compare pre and post weaning. We've done a bit of that, but we want to investigate further the effect that those rotation strategies have on parasite burdens, and also, of course, quantify the labor cost that it might represent to invest a lot in those paddock grazing, so that we can better estimate the actual benefits in terms of profit that they represent. So there's many more questions that we would like to address, of course, and I'll be keen to hear your views on that. So please don't hesitate to share that with me, and I'll be happy to take questions at the end as well. Thank you very much.
Excellent. Thank you very much, Aurélie. I should have said, actually, one of the farmers on our first night is a grass check farmer. So I've mentioned his data, and it's really good because you've reinforced a few of the things we've talked over the past couple of days, and also made me think a little bit differently about paddock grazing pre-weaning for using lambs, and thinking pure is probably better. So that's fantastic. Thank you very much. And there are questions. If you're able to have a quick look at them in the question and answer, that would be fantastic. If not, we'll get to them later.
Okay, no problem. Thank you.
Next, I would like to introduce our second speaker of the evening, Dr. Sarah Morgan from Rothamsted, and she's going to present about the rotational grazing versus set stocking trial done at North Wyke in Devon. So I'll hand over to you, Sarah. Thank you.
Hiya. I'm Sarah Morgan from North Wyke in Devon. I'm going to talk about the project I've been working on, which is assessing the environmental impacts of grazing management. So for those who are not aware of where North Wyke is, we're right down in the southwest of the UK, right in the middle of Devon, on the doorstep of Dartmoor. So in terms of the project I've been working on, it's a sub-project of a larger project called Agritech Cornwall, which was established in late 2017, basically to stimulate growth in the agritech sector in Cornwall and the Isles of Scilly. So as part of the Agritech Cornwall initiative, it helps to encourage collaboration between researchers and SMEs that are based in either Cornwall or the Isles of Scilly, as well as delivering scientific outputs from the range of projects that it has funded. So as I say, the cell grazing project is one project, and there's other projects that are focused on, say, soil carbon, and some that are focused on multi-species lays. So the motivation for setting up the cell grazing project was basically to fill a knowledge gap in terms of what the environmental impacts of rotational grazing are. There's a lot of evidence to back up the production benefits, but in terms of the environmental benefits, the evidence is very much on the anecdotal basis. So we wanted to sort of see if we could sort of find some empirical evidence to either back up those anecdotal claims, such as improved carbon sequestration, reduced inputs, etc. And overall, we wanted to investigate whether cell grazing would be a route to achieving sustainable intensification for grazing systems. And as the project has progressed, it's become sort of increasingly applicable to policy as well. So we've recently gone through Brexit, and the UK are developing their new agricultural bill, the phasing out of direct farm payments that will happen over the next 6 to 7 years, and also the introduction of the environmental land management scheme. Below on the bottom left, you can see some of the SMEs we've already collaborated with, which has primarily been through precision grazing, who are based in Cornwall. So the aim of this study was, as I say, to quantify and compare the environmental impacts of contrasting grazing management systems. So within this study, we're comparing set stocking to cell grazing, which commercially is known as techno-grazing, and we heard a bit about techno-grazing on Monday. So the study started in April 2018, and we're using dairy cross beef steers for the grazing. And we're grazing a typical pasture that's found in the UK, which is an improved, mainly perennial ryegrass ley, which was last reseeded in 2013, with a predominantly perennial ryegrass mix with a little bit of white clover. And to bolster the sort of scientific element of this study, we've used a replicated statistical design in the layout of the experiment. So this is a top-down view of the experiment. The sort of paddocks that are outlined in yellow are the set stocking paddocks, and the ones outlined in orange are the cell grazing or techno-grazing paddocks. You can see on the techno-grazing paddocks the build-up of the grass wedge. So I think this image was taken at the end of 2019-ish, so we were quite late into the season at this point when this image was taken, but you can see that we've built up a nice grass wedge. And you can roughly, if you strain your eyes a bit, see where the cattle are in the cell grazing versus the set stocking. The little triangle in the middle, you probably can see some cows dotted around there as well. They're just some spare cattle that we use to take on and off the system as and when needed. So this is what the system looks like on the ground. So on the left, you've got the set stocking animals, and these are in areas that are 1.75 hectares in size, and they've got constant access to the whole 1.75 hectares for the whole grazing season. We don't change the area that they're allocated at all. And as I say, that is constantly grazed with no active management of the sward height. So once ground conditions and weather conditions allow, we turn the cows out and they basically stay in there for the grazing season. And if the grass gets too high, it does. The only threshold that we have set is if the average pasture cover goes below 2,000 in these paddocks, then we will take the animals out because we won't be able to sustain their growth rate. And within these set stocking plots, the stocking rate is fixed. So we keep the same number of animals throughout the growing season. So we don't change the number of animals either. So it's a very strict set stocking, so to speak. So we don't change the area that they're allocated or the number of animals that are on there. In the little inset, you can see that they just have access to a normal water trough. And then on the right, you can see a group of the cell grazing animals. So we use temporary electric fencing to enclose them into their daily allocation area. And we use a front fence and a back fence, as well as a safety break ahead, which is just out of shot. So the cell grazing plots are a total of 1 hectare in size, and that's split equally into 42 cells. And these are rotationally grazed. And as I say, the daily allocation is adjusted to balance the feed supply and demand. So they're not necessarily grazing, say, 1 cell a day or 2 cells a day. Sometimes we have an allocation of 1.25 cells, 2.75 cells, but we closely try and balance the feed supply and demand. And we also use a variable stocking rate. So if we find that the grass ahead of us is getting away, then we'll put more animals in to increase that feed demand. And equally, if we're becoming short on feed, then we take some animals out to reduce that feed demand. So it's a very sort of closely calibrated system, in contrast to the set stocking, which is just put the cows out and let them get on with it. In the inset, I just show that the cell grazing animals, we're using these micro troughs, which are by KiwiTech. So just to show that the difference in drinking water availability / supply, because that's something that I'm interested in to look at in the future. So within the project, we're taking pretty much a whole system approach. So we're taking data from the soil level, pasture level, animal, and right through to the meat or product quality. So this is just you probably can't see the labels on here, but it just shows the variety of different data streams that are being collected within this experiment. In terms of starting in 2018, we had a pretty bumpy first year. So we had a delayed turnout of the cattle because we had a very wet spring at the start of 2018, which meant that the grass was growing nicely, but we couldn't turn the cattle out because the ground conditions were too wet. Once we were able to get them out and the sun started coming out, the grass then went wild in terms of growth and got way ahead of us. So to try and manage that, we didn't at the time have an option to put more cattle in. So we kind of sped up the rotation to try and just even the quality of the grass across the system, but at the expense of getting tight residuals. But at that point, we didn't really know what was around the corner. And in the middle of 2018, it decided to stop raining, which is very atypical of being in Devon. And as you can see from these photos, the grass got pretty dry. And as you can see from the graph there, in June, it basically rained a total of, I think, 4 millimeters for the whole month. As I say, it was quite a shock to the system and also made things pretty challenging, especially considering this was our first year for setting up this experiment. So that was a pretty big challenge, but because of the grass that we had built up in the spring, we used that surplus to feed them through the dry period. So we did manage to actually keep the cattle on the experiment and didn't actually need to feed any supplementary feed, but that did have a knock-on effect on their performance, which I'll show a bit later. For 2019, things were a bit more normal. The grass was green and it was raining, but not too much, which was good. And then we had another bump in the road in terms of 2020, where there was a global pandemic. So the first lockdown kind of coincided with when we would normally turn the cattle out. So that kind of put a halt to carrying on with the experiment while we figured out how best to deal with a cattle grazing experiment in the middle of a global pandemic. But luckily, due to the time critical nature of the work involved and not being able to sort of delay the turnout of the cattle too long or any of the measurements, then we got special permission to carry on the bare minimum, let's say. So we did manage to get a full grazing, or virtually a full grazing season last year as well. And aside from COVID, again, it was another sort of average, if you can say there's ever an average year for grazing, and the cattle did pretty well. So if we move on to some of the preliminary results that I've collected so far, this is an overview of the grazing days between the years. So at the top we've got 2018, 2019 in the middle, and 2020 at the bottom. It was funny hearing on Monday some of the farmers were saying that they were expecting to turn out in the next couple of weeks, and there's one farmer that was stuck not turning out till the end of middle of March. in the location that we're at, we're on very heavy clay soils, which means for about 4 or 5 months of the year, the soils are just completely waterlogged. So we're very restricted as to when we can turn the cattle out. So the sort of average turnout time for where we are is mid-April. So in 2018, we had the same turnout for both the set stocked, which is the SS, and the cell grazing CG, just because the experiment had to get underway, and we housed at the same time at the end of that year. 2019 meant I did have the flexibility to try and turn out some of the cell grazing animals earlier, and did manage to do so. The gap at the end of April to the beginning of May in the set stocking is because the pasture cover got below 2,000 kilograms per matter per hectare in the set stocked paddock plots. So as I said, that's our minimum threshold. So we took the animals off for welfare reasons, and then they managed to go back on in May. Basically, we accidentally overstocked the system in April, and we didn't get the expected grass growth that we were hoping for at that time, so they had to come off. So as you can see, in 2019 at least, I've managed to increase the number of days on grass through the cell grazing system versus the set stocking, and managed to do that again in 2020 at the end of the grazing season. As I say, because of COVID, starting the experiment was a bit up in the air, but we did eventually get going. And then in terms of the fertilizer inputs, we're on very low index soils. So we're index 1 for P and K, hence why we put P and K on each year. In the first year, we were going to go out on a limb and put no nitrogen on, but in hindsight, that was probably not the best idea. So in 2019 and 2020, I decided to put some nitrogen on, which is only about 100 kilograms of nitrogen per hectare, so nothing too intensive. These are the stocking rates that we've achieved year to year. So this is just a median stocking rate for the whole year. I've got livestock units on the left there for people who may deal in old money, and then the kilograms live weight per hectare on the right. The set stocking plots are averaging at around about 1,500 kilograms live weight per hectare as their sort of carrying capacity. As you can see in the lighter blue bars, the stocking rate or carrying capacity of the cell grazing is actually slowly going up year to year. So we've gone from just under 2,000 to just over 2,500 kilogram live weight per hectare. In terms of soil chemistry, we've looked at a few different things. So your usual stuff like pH, organic matter, P and K. We've also done some micronutrients, but I haven't got that data collated yet. In terms of the pH, there's not that much difference between the systems all year to year at the moment, other than it's gradually sort of creeping down. But if you look at the numbers on the y-axis, there's not an awfully big difference between the numbers. Organic matter from year to year is increasing on both systems. So the set stocked system averages are in the dark blue and the cell grazing are in the light blue. But the organic matter is increasing at a faster rate, it seems, on the cell grazing. I will add that none of this data has been statistically analysed yet, because I need sort of yearly replication before I can sort of look at the statistical analysis, which I'm at the point at now with 2020 and hopefully 2021 data as well. In terms of phosphorus and potassium, as I say, because we're on the very heavy clay soils, most of what is applied onto the soil actually gets locked up by the clay particles. So it's sort of very difficult really to increase the phosphorus or potassium. It needs to be done over a very long time period, adding little by little. As you can see on both systems, both P and K are increasing. phosphorus is possibly increasing at a quicker rate on the cell grazing versus the set stocking, and possibly potassium as well. With the nature of this experiment, and also the wildly challenging year of 2018, it's sort of knocked the differences back a bit. So we're only now really starting to uncover the differences arising from the different grazing management, because this is all based on sort of biological processes that have had to adapt to the different grazing management. There's sort of a time delay as to the biological process adapting to the new management, and then also showing or displaying that difference. I also take botanical composition data each spring and autumn, before grazing and after grazing. So this graph is a bit sort of data heavy, but generally speaking, in the springtime, from year to year, the perennial ryegrass percentage is going up in both the set stocking and the cell grazing. It seems it's going up quicker in the cell grazing, and with the higher percentage of perennial ryegrass, that is outcompeting the other grasses, which mainly includes Yorkshire fog, because we're in sort of, as I say, quite a damp area of the UK. Yorkshire fog is our main weed species in terms of grass. And then this is the data for the autumn. So a similar sort of pattern in terms of the perennial ryegrass percentage going up, and that's outcompeting the other grasses. In terms of the white clover, we're kind of missing the window where white clover is most active, which is sort of June, July, August time. So we're not really capturing any effects of the grazing management on the white clover, because we're not doing the botanical composition at that time. And that's mainly for practical reasons, trying to do this kind of thing in the field with the cattle in there. The cattle are very inquisitive, as you probably know, and they like to either steal stuff or yeah, practically trying to do science around cows is sometimes a nightmare. These are the average pasture covers. So during the grazing season, we actually take plate meter readings weekly, but on these graphs, I've just represented the monthly averages, just to get sort of an overall picture. You can see, as in 2018, where we had the massive excess of grass early in the spring, and then that excess actually carried us through that dry period between June, July, August. 2019 managed to get average pasture covers similar between the systems, and then in 2020 the pasture cover on the cell grazing was a bit higher, which probably means we could have possibly put some more stock on the cell grazing systems, but it's kind of a learning process as we go and trying to optimize the systems, and also because the weather has a massive effect on the performance and growth rate of the grass, then it's difficult to forward predict what's going to happen. I haven't converted the average pasture covers to kilograms dry matter grown, because I need to do some calculations trying to estimate the intake of the animals on the set stocked to account for that, as well as the grass growth rate, to then kind of calculate the tonnage of grass grown on each of the systems. In terms of live weight performance, the SS stands for the set stocked and the CG for the cell grazing. The daily live weight gain, as you can see in 2018, was much lower than our target would have been. But as I said, we did manage to keep the cattle out on the pasture without having to supplementary feed them or do much intervention. As the years have gone by, the daily live weight gain has increased on both of the systems, but you can see the live weight gain on the set stocked systems has always been higher than the cell grazing, and that's can be seen at each year. and that's also reflected in live weight gain per head. So the total live weight for the grazing season per animal was higher for the set stock than the cell grazing. But one of the metrics that's becoming more popular to look at in terms of rotational grazing is the total live weight gain per hectare rather than per animal. And you can see in 2018, 19 and 20, that was higher on the cell grazing, just because you're improving your utilization of the grass. So to put that into context, there was a 10% difference in 2018. As I say, 2018 was a very challenging year. 2019, there was a 61% difference in terms of output per hectare. And then in 2020, a 39% increase. And in 2020, we actually achieved over 1,000 kilograms of live weight produced per hectare. We've also looked at some of the behavior aspects of the animals. So in 2019, we put some pedometers on them, which is a challenge in itself because most of these sensors are made for dairy cattle, and the way to capture the data from them is when they're in the parlour. Whereas because these are continuously grazing outside, then we had to come up with a solution that would be able to capture the data in situ in the field. So we worked with Ice Robotics, who produced this little trailer you can see in the picture that's got the sort of data capture, download and transmission all in one, that's solar powered with some battery backup. The graph in the top left is basically the step count per 15 minutes throughout the day. So the darker bars are the set stocking and the lighter turquoise bars are the cell grazing. So you can see in the morning, the sort of the step count or behavior of the animals is pretty similar, apart from the cell grazing animals, which have to wait until about 9 o'clock in the morning to get their breakfast, whereas the set stocked animals can go and get their breakfast as they want. But I was interested in to see this big difference in the behavior in the afternoon. It's known that cattle usually have their largest grazing bout sort of later in the day, which can be reflected by the sort of peak in step count around 6 p.m. in the set stocking, but we didn't see that in the cell grazing. In terms of the difference between the systems, as an average, the cell grazing animals were doing about half the number of daily steps compared to the set stocked, which is a significant difference. It's not surprising given the cell grazing animals are in such a smaller area compared to the set stocked animals, but there was no difference in the time spent standing or lying, and also there's a bit of a difference in terms of the number of lying bouts, but I need to look into this data a bit more. We also looked at carcass quality. So we slaughtered some animals at the end of 2019, and this graph just shows the tenderness, which was a significant difference between the systems, but in real terms, the numbers are so small that it doesn't make a sort of real world difference. To put the hardness into context, anything below 4 kilograms is deemed tender, so all the meat that came off those animals was tender. I've also got a lot more data that I need to consolidate and present, but that gives you a taster of the kind of thing that we're doing. And as I say, we're now starting to see the differences between the systems, and hopefully the 2021 data will sort of solidify those trends. Currently, 2021 will be the last grazing season for this project, but we're actively looking for some more funding, hopefully, to continue it on longer. So that's it from me. Thank you very much.
Thank you, Sarah. That was excellent. I think you're capturing so much there. We probably could have continued for a lot longer. I guess I'm just going to ask a question selfishly. It's Chair's right. Do you find you're capturing so much data of the whole system, from the species composition to the animal welfare to the meat quality, and you recognise the need to capture all this, but do you find sometimes you're struggling with focusing on an area that you like more, and and staying away from an area you dislike more? Do you find that balance quite hard?
Yeah, so previous to doing this project, I'd kind of come from the meat quality aspect of things, and that wasn't originally designed into this experiment, but I kind of shoehorned it in because it's one of my areas of interest. But as I've been sort of doing this project, then I've kind of come to appreciate that collecting data at all the different scales is quite important to kind of fully understand sort of the processes that are driving, you know, the changes in terms of productivity or the botanical composition and stuff. But it's a lot of data, and there's a lot more mining of the data I can do in terms of comparing things with each other and trying to bring it all together. So yeah, but balancing that with being out in the field and collecting the data is a bit of a challenge.
I can imagine. Well, thank you very much, and I appreciate you keep going through the COVID lockdown to do this essential research. So thank you very much. I am going to now introduce my colleagues who I know very well. Claire Morgan-Davies, who is a researcher up at our Hill and Mountain Research Centre near Crianlarich, and she will be joined with Malcolm MacDonald, who is one of our esteemed SAC consulting colleagues at Inverness. So I'll hand over to you, Claire. Thank you.
Thank you, Poppy. Sorry, I was on mute. I should know how to do it by now. Thanks for the introduction. So I'm going to tell you a little bit about some pilot we've done at SRUC and beyond using the virtual fence, no fence. And it's not really my work, and I really want to acknowledge my co-author. So Malcolm MacDonald will do a double act with me in that presentation from SAC Consulting, but also my colleague Tony Waterhouse from SRUC, and my colleague from France, Laurence Dupuis from the Livestock Institute, so IDEL, and I will explain a little bit more where I've taken results. So if I can. Yeah, so little outline of what we're going to talk about today. First, I will explain quickly what no fence is, and then I will present a little bit of the SRUC Carlton pilot that we're hoping to do for the cattle. Then Malcolm will take over to talk about the risk on farm use for the cattle, and then I will touch on the trial that has been made with the sheep in France and some conclusion. So the virtual fencing we're going to present today has been developed by the Norwegian. It's called No Fence, and originally it was developed for goats. And in Norway, the goats are roaming quite freely in the rangeland in the north, and there is no fence. So they developed that system to try to keep the goats inside. And then it worked quite well, and I will explain a little bit how the technology works. And they are now keen to expand into the sheep and the cattle sector. And so they were quite interested to have some pilot with cattle. So how does it work? So it's combining a kind of a remote control sat-nav with a cow-worn electric fence. So the way it works is it uses a smartphone, and you can say where you want your paddock or your field to be, where your boundaries are. And in that case, for the cows, you've got a device that's worn by the animal, and then you've got an unpleasant stimulus. So when the animal is reaching the edge of your virtual paddock, you first get a warning sound, and then when they reach the virtual fence line, you get an electric pulse that will push the animal away, or at least teach them to not go further beyond that boundary. So there are 4 big companies that are developing the technology. So Shepherd, Vance, Alter, and No Fence. But really, as far as we know, is No Fence is really the only company that's fully commercial now, and we can get the kit in the UK and in Europe. And as I say, they are fully commercial and well developed for the goats, and they are trying to open the market for cattle and sheep. In the UK, there is some pilot farm, but not many, probably only 20. And it's mostly hill farming. And what I will show you is what we've done on some of the hill farm or conservation grazing. So first of all, what we were hoping to do at Kirkton. So that's a kind of a view of our farm. So all of these is our research farm. It's 2,200 hectares, so we're based in that area of Scotland, so quite a long way from Northwick, from Sarah earlier. And that's taken on a good day. So it's pretty high mountain. We've got a Monroe, so 1,000-meter Ben Hallam there. So big areas, and obviously not many fences at all. So there is one fence line in that direction here with a neighbor, but everything else is not fenced at all. So we thought it was quite interesting to try to pilot some of the no fence collar for the cows on our farm. The farm's got 1,300 sheep, and we've got roughly 30 cows. We were all set up to try with the animal, and then of course COVID hit in March last year, and so we've not been able to put it in place. I'm going to show you what we plan to do and what hopefully we'll be able to do later on in the year if some of us are ever allowed back on the farm. So just a little picture of what it looks like. So as you saw on the earlier picture with the goats, that's the sheep or goat collar from 2018 with the battery, and that's the one we're using for the cattle. And Malcolm's got more photos of what's been done on commercial farm as well. It works with a solar battery, and I think there is some idea to upgrade it a little bit more. So they're still working on the design. So why using no fence? Well, you saw the area of our research farm, and I should say one of across our farm, we've got the West Island Way, which is a long distance path, and we've got a lot of tourists and people walking along there. So we're quite keen to try the virtual fence to avoid having that mixture between people walking around and cattle being kept in a place. So it's just a little example. So it's on the west side of our farm near Tyndrum, so that's the area. So we're trying to have fence line on the top right and bottom to try to keep the cattle away from the fence itself so they don't damage it or try to destroy it. And on this side was really, on the left boundary, was to try to keep this cattle off the West Island Way to avoid, as I was saying, contact with the tourists, with dogs, etc. And we're also keen to have an exclosure inside the zone to keep the cattle out of the unfenced dangerous area. So that was one little pilot we wanted to do at Kirkton, and hopefully we'll do it later on in the year. So that's trying to see two aspects. So keeping animal away from some dangerous zone, or keeping the animal away from contact with other things, tourists, for example, or cars. But if we go back to the rotational grazing, which is after all the discussion of tonight, we wanted to try it as well. So if we go back to the map of our farm, we've got a woodland area here. On that section here is the railway line from Crianlarich to Fort William. And we were keen to try a rotational grazing on that area of the hill. So on one side, the woodland, and on the other side, the railway line. So if we go a little bit in more detail, so again, that's the railway line I was showing you here. So it's more of an aerial view. That's the research farm here. So the first idea was to have a paddock roughly that size and keep the animal, the cows, in there. And then maybe after a few days, we would put the fence a bit differently. So we keep one area the same, but we extend it on that side. So the animal are not too changed or too spooked in a sense. So they're still part of their old grazing area, but they've got access to another part here and a bit shorter on this side. And then eventually we would move to that area here and do it that way. So a series of rotational paddock in a sense. And so it's easier to move the cattle. And then once the cattle have moved in, we can close off the old section. So that's the way we would envisage a farm, a rotational grazing based on natural pastures. So it's not the lovely grass that Aurélie was showing in Ireland. It's not that level at all. But that's how we are trying to hope to do it at Kirkton once we've got access again to be there. So I'm going to leave it now. I'll shut up for a minute and let Malcolm take over. So Malcolm, if you want me to pass the slides, just shout next, and I'll press the button. But the floor is yours, Malcolm.
Okay, thanks for that, Claire. Yeah, so my name is Malcolm MacDonald. I'm a consultant with SAC, managed to sneak in with these researchers tonight. I started off and facilitated a risk group looking at virtual fencing, just because I had quite a few inquiries from clients and other farmers in the area wondering what virtual fencing, if it was near the market or if it was going to be available soon. So when I saw the chance for the risk group, I started up a group with a few farmers and crofters who were interested. We kind of started things in late 2019. We got kicked off in late 2019 and had our first and only in-person meeting in December 2019. And that's when we started to talk to No Fence too. I would say, like Claire said, Tony Waterhouse was very involved in this project too, and he made the initial contact with No Fence and has been the kind of research science side of things. So we started discussions with No Fence, and initially the plan was, before kind of COVID came in, hopefully, like Claire was saying, we'd get a few collars over to Kirkton and we'd be able to see how they worked in the cattle there. And that would give the farmers involved an opportunity to go and see the collars in action kind of, and make a decision about if they wanted to purchase them or see if they thought they'd work commercially on their farms. But with manufacturing delays and various things, that wasn't possible. So in kind of mid 2020 in the summer, or kind of late spring, the group decided to look at a kind of group buy to No Fence directly. So again, with COVID, things weren't moving fast, but we eventually got collars kind of on the ground in September 2020. So out of the kind of 7 farmers and crofters in the group, 3 or 4 of them have been using the collars to a reasonable extent. For some of them, it was too late for the grazing season, so it wasn't quite possible to try them out this year. Do you want to move on? Next slide, Claire, please. Yeah, this is just a picture. This is at Corrimony Farm, which is outside Inverness. I'm just showing them in use here. Like the previous picture, that the collar there, actually, that bit on the side is a solar panel, and then the green tab at the bottom is the battery where it's fixed in, and then it just hangs around their neck, as you can see. So it's quite a robust collar, and the cattle version certainly is reasonably heavy too. I've seen them and kind of held them, so they're quite a sturdy piece of kit. And next slide as well there. And this picture too is just, again, at Corrimony, showing the cows out in the hill. I think that the risk group was titled Virtual Fencing and for Hill Cows. So this picture really kind of is nice and sums up the work the group was trying to do. The next one, Claire. Yeah, so thoughts and lessons learned. There was no formal trial as part of the group, but it was just really just using the collars in a commercial farm and seeing how they worked. The main takeaway is that on the whole, they worked very well. You know, for a lot of the farmers out of the box, they worked as they were sold, and did the job very well. The cows, they really do respect the virtual fence. With a bit of a training period, they really, you know, just like they respect as much as a standard electric fence, for example. They don't often go through it at all. I think we had, out of the kind of 40 or 50 collars which have been in use in 2020, I think there was a handful of cows breaking out of their virtual field, and most of these instances, the cows actually went back in themselves. The farmer, you get on the app, you get an alert if a cow breaks out, so you're aware. But by the time the farmer and crofters had gone to see the cows were back in, because essentially it works kind of like a non-return gate or non-return fence, which is more kind of intelligent than any physical fence would be, because if they break out, the noise stops because there's a warning noise, then the electric pulse. But if they go through it, that just stops. And if they come back with their own accord, there's nothing to stop them. But then next time they turn around, they'll get the warning noise again. So they can break out a couple of times and train themselves to it effectively. One kind of discovery was that the cows do get a little wound up when they first have the collars on. Just the presence of something below their necks was, some of them did get a bit flighty when they're put on, so that needs to be kept in mind. And No Fence advise a kind of a training period of having the collars on for a few days, you know, 3 or 4 days to get used to it, and then another couple of days before you switch on the collar, and then set them up in a training paddock, just with the fence on one side as opposed to 4, so they can encounter it. Another key concern going into looking at the collars was the battery life. A lot of the group members were worried about having to be replacing batteries mid-season in the grazing season and taking cows in some instances in off the hill, which is quite a lot of work, charging batteries and putting them back out. But so far they've been pretty promising on the battery life. They've stood up quite well. I mean, the collars went on in September, October into December when there's quite a short day length, especially up here, and some of the group members were up in Altnahara, which is even further north of a shorter winter day length. Some of those collars were coming off still with kind of 50-60% battery life in December after quite short winter days. So we're reasonably confident, and no fence are quite confident, that during a summer grazing period, the battery life would be, the solar panel would keep it topped up and it would be fully self-replenishing, which is quite encouraging. The other point there, reception. To update your fields and to link back to your mobile phone or your computer, the collars use 2G mobile data like your phone, and you need to have reception in your area for it to work effectively. One of the farmers did have a bit of bother with them dropping in and out of signal, which drained a bit more battery and made it a bit trickier to update them and keep track of the cows at all times. Because when you've got full reception, then you can pretty much track where they are at any time. Every kind of 10 minutes they ping and update it. Collars falling off was another concern, but there's been a handful of them. Again, probably single figures with the total cows. Each farm maybe lost a couple of collars, but they were in most instances found quite easily because of course they're GPS trackers, so you can just look at their last location and pick them up, put them back on. Next slide, please, Claire. And yeah, kind of almost conclusions here. The cost, I mean, there's no secret to the cost. It's on No Fence website. If you look, they're sitting about £260 a collar, and then you've got your subscription fee to go along with actually using them, which is another about £60 a year. It varies, but that's kind of the price you'll find on the website. For a lot of the farmers, it struck them as slightly too expensive. I mean, the farmers most of them dip their toe in with 10 collars or maybe 20 collars when they've got 30 or 40 or 50 cows. Some of them went for collars for all the cows, but not all. The gut feeling was it's probably too expensive if you've already got a good fencing and good infrastructure on the farm. But some of the group members, have quite large areas without any fencing at all, and were contemplating spending tens of thousands of pounds on actual fences. So in these situations, the cost is stacking up relatively well. So there's situations where it can be cost effective, I think, was the kind of takeaway. The other thing is if the collars last 10 years, then your £260 comes down to £26 a year over the lifetime. That's maybe okay, that's fine. But right now we just don't know how long they're going to last. They do certainly feel quite robust. Or the other worry is, will they be surpassed by something more updated too? So yeah, quite cost effective for farms with no infrastructure. And the other angle, which we mentioned before, would be conservation grazing, of course, where there's a bit less commercial pressure if you're presumably with a management scheme or something, which is bringing in a bit of money to help pay for that, because of course the collars can help you manage a sensitive habitat effectively. And the final slide for me there. So a few things if we'd got the collars earlier in 2020, we're really hoping to try and do a bit of rotational grazing on some of the farms, but just by the time we got them, the way the grass growth was going, it wasn't going to be that effective or that useful. So it'll be very exciting to see if they can be used as that kind of rotational grazing tool, because I think they can be done. I don't see any reason why not. And one of the farmers has been moving them from a few paddocks, and it worked very well. They did graze up to the virtual fence quite close, so it wasn't too fuzzy a line. So it was quite precise in that regard too, once the cows were used to it. So that'll be something very exciting to try hopefully in 2021 once we get into the summer and the spring. And then virtual herding was another kind of step more again, as in just drawing the cattle in off a large kind of hill or even a small field, just drawing them back to the steading on the farm and automating that process. That'd be very interesting to try that. And my final point there is about heat detection and monitoring. The collars have pedometers in them effectively, or accelerometers, so they are tracking animal movement in these regards. And from some of the discussions we had with No Fence, it seemed like all the technology hardware was there to do that type of thing, but they were just focusing on the fencing aspect initially. So I think if it can become more of a heat detection and health monitoring tool as well, it could be even more benefits and might be quite useful. It also might be more useful in dairy herds, or it might be more cost effective in dairy herds if it can be slightly tweaked to sit into these things. But that's a very quick overview of the risk group and the work we did. So back to you, Claire.
Thank you, Malcolm. So it's nice to say it worked on the ground. So hopefully we'll get some of that information as well once we do it at Kirkton and try that rotational grazing plan that we had. So what I want to show you a little bit more now is I was lucky to have a very nice colleague in France who have tried the no fence on sheep, on ewes. So I'm going to present you their results. So, and as I say, Laurence is in the audience, so there is any question that she might be able to help me. But I just thought it would be interesting for you to see what happened with sheep as well as cattle. So it's been tested on a demonstration farm in France called Maurier. It's one of the what they call DG farms. So it's a farm with a lot of precision farming tools, and it's led by the Institut de l'Élevage, IDEL, so Livestock Institute. And as you can see, it's in the west of France. And the sheep they've got there are the Mouton Vendéen, as you can see on the picture. So they've tried the no fence collar for use back in October this year, or last year rather. And so very similar to what Malcolm was showing. So you've got the little chain here that holds the box, and you've got the battery, the GPS, and the accelerometer, as Malcolm was mentioning earlier, with the chain here connected to the battery, and the solar panel are on the side. I know people might think it's more sunny in France, but when they tried that for over a week, it was raining all the way, but it still worked. So what's it done? They had 20 ewes, so Mouton Vendéen breed, and over these roughly a week or 10 days, they've started to do different approach. So that was the area they were looking at. It was roughly 1 hectare. So they had a physical fence, but one of them was a bit broken. So it allowed some access to another pasture on the side here. And that's where the ewe were allowed. So for 4 days, the ewes had the collar, but it was not turned on. It was just for the ewe to get used to having the weight around their neck. Then for 2.5 days, they started to put the virtual fence. So the virtual fence was here in green, and the animal were contained in that areas. And after they did 2 fences changes, so from that section to that one here and that one there. So just to see how the animal would react once the fence boundary was changed. That was for roughly a day. And then in the day 8 and 9, what they tried is they took 10 Mouton Vendéen out and replaced them by 10 naive ewes, which was a cross of a Ile-de-France cross Romanov, so just those are 2 different breeds, for 1 day, and see how the animal, the new one, were behaving compared to the one that's been with the system for a week. So that was the kind of experimental design, I would say. So what did they see? Like what Malcolm was saying with the cows and with his farm in his group, the ewes learned very quickly how the system worked. So that graph here shows the electric pulse, the stimuli, and then at the bottom here is the sound. So after 1 day, so the first day there were quite a few pulses that had been recorded, a few alerts, and the same with the sound as well. But after 1 day, there was hardly any breach or any attempt to move toward the fence. So there were nearly no alerts. And you can see when the virtual fence was changing, so after a few days, as I was explaining earlier, so again, very few alerts for either electric pulse or with the sound. And when we've got the new ewes, the naive one mixed with the one that knew how the system worked, again, there were a couple of alerts, but hardly any. So what they found as well was there were some difference between the animal in response to the stimulus. And then there were some difference among the use as well in terms of exploring the virtual fence limit. So some animals were more curious than others. And especially when they had the naive use, they noticed that the naive one were learning quite fast from the one who already had the color. And when the noise was there, all the sheep kind of reacted to it. So there was a kind of a flock reaction because the animals are quite gregarious. So in terms of practical use, so that's what you see on your mobile phone, a little bit what Malcolm was showing earlier and I was showing in the earlier slides. So that's where the fence was put. So what they found that it was easy to create these virtual fence for the pasture once you've calibrated your farm. And it was also easy to associate the color to the pasture based on that app. And it was quite easy to put the color on the sheep. Like Malcolm was saying, the battery life was good. I mean, okay, it was only a week, but and hardly any uses despite all of the stimulus. I think after a week, the battery were still at 85%, so it was fine. However, there is two systems. So one works on the phone, but you can also have the application on your computer on the web. But and the colleague found that maybe that application on the web could be made. Some improvement could be made. It was not that fantastic, but on the phone app, it worked very well. And in terms of investment, so going back to what Malcolm was saying, so the French paid 200 euros for a collar. So I think the prices are a bit different from what the price Malcolm was quoting because the cattle one is probably bigger than the sheep one. And then it's roughly so 175 pounds for a collar, 70 pounds for an extra batteries, and then having the charger as well. And again, it's a daily charge like Malcolm was mentioning. So it is a financial investment that's quite important to consider. In terms of future work that they want to look at, and that I'm really keen to see what results they will get. So they want to look a little bit more into the animal welfare and in relation to that virtual fence. So dwell a little bit longer on that. And again, using the virtual fence for rotational grazing. So we're going back to what we were saying earlier, what we're trying to hope to do at Kirkton and what Malcolm's group are doing. And obviously the French want to do the same with their sheep and see if it's possible to push the sheep away, so herd them away. And also look at the working time for the farmer in relation to the virtual fence. So does it take time, how long it takes to move the boundary on your phone, and how does that work? So maybe look at the cost benefit aspect based on that as well. And lastly, the trial were done on a relatively flat area, but they're quite keen to try it in more mountainous areas and maybe see if it works to only have the collar on some sentinel ewes rather than the whole flock. Again, because the flock is more, the sheep tends to be more together than maybe some other type of livestock. See if you can maybe only have the collar on some animal and not all of them. So that's the next kind of a trial they want to proceed and see what we get out of that. So in conclusion to that talk tonight, so between what we want to do at Kirkton, what's been done by Malcolm and what's been done by the French colleague, I think there is definitely scope for use of these no fence or these virtual fence with both the cattle and the sheep. We've kind of shown that it can work on commercial farm, and there are some benefits, and we still need to look at the cost benefit really between the price and what you get out of that. And rotational grazing is something that will be envisaged very soon. And so hopefully, if we had the same kind of talk next year, then we should be able to show you more result than just we hope to do that. There are some barriers to implementing, but maybe not the one that people would think of. So the battery life, for example, is good, or the connection with the GPS and the Wi-Fi, like Malcolm was talking about. If you've got a 2G, it should be okay. But it could be, again, a game changer in some areas where, as Malcolm was saying, or as what we've got at Kirkton, where fencing is just impossible to imagine for the cost of the area we want to look at, or it's too expensive to maintain. And again, as Malcolm was alluding to, there is potential for conservation, grazing, and the sensitive habitat. And the no fence, I know, is being used down in England just for that conservation aspect. And I think that's all for me and my lovely co-presenter tonight. And I want to thank my colleague from the Institut de l'Élevage and some various projects that are funding or interested into that project. So I'll shut up now. Poppy, if you want to take over.
No, that's great. Thank you so much, both of you. It's really very promising for some of our more challenging and unfenced environments, as you said. So really good to get that practical feedback. So thank you very much. For our final speaker this evening, we need to wish good morning to. It's Catherine Tozer, hailing from New Zealand, and she is going to talk us through the deferred grazing trials that she's been part of there. So I'll hand over to you, Catherine, if you're ready. Thank you.
Yeah, and I'll just, you can hear okay? Just trying to share the screen. Oh, hang on. Is that coming through, is it?
Give it a moment, it might do.
Nope.
Not quite
That's
yet.
okay. Well, I'm just doing that. I'll just talk you through. Oh, I don't know why it's not working. Hang on. Oh, here we go. Now that should be right.
You've got it.
That's got it. There. Okay.
Perfect.
They're right. That's up all right, is it?
Yeah, and if you just want to hit present, yeah.
Oh, it's having a... That's got it. Excellent.
Perfect. And if you want to switch the display settings again, yeah.
That's got it. Cool.
We've got the note screen, that's all. Oh yeah, perfect. Sorry, got it now.
Right. So just for some context about this work, this is work specifically for New Zealand hill country sheep and beef farmers. It's relevant really throughout New Zealand. The thing that we're faced with is the sort of thing that earlier on with North Wick, that Sarah was talking about. What do you do when you're in a rotational grazing system, but you're getting too much feed in the spring? The feed supply is typically quite lumpy. It can be quite dry over summer, depending on the region you're in. You get good growth in autumn, it slows down in winter, but often I'll just go up the top side, often in spring, you're finding that you get a lot more feed than what the farmers are able to use. So the farmers are using the tool here of deferred grazing to try and better match the livestock feed supply and demand. I think from some of the work I've read, it might be referring to deferred grazing in the UK system might sometimes mean talk about autumn save pasture. As in New Zealand, we're very much talking about focusing on spring in rotational graze systems. So here on this top side, you can see one of the farms in a summer wet area where we're working. And it's actually one of the field sites when we were comparing deferred grazing to standard rotational grazing. So in the deferred system, you're actually taking some paddocks out of the rotational grazing system and locking them up from spring until the end of summer. So in the paddocks that are locked up, you're going to be letting everything go to seed, and it looks terrible. You can see there actually in terms of the amount of seed head that's showing, how you get pastures that kind of look like hay. But there's quite big advantages to that. So just to make sure we're on the same page, I'll just go to a slide which you can read. So this is what we're recommending to farmers in terms of how to defer a pasture. So just let you read that for a moment. So some of the keys there are knowing what do you have in your paddock? What are the species that are there that you actually want to improve the abundance of? So in the systems that we were talking about, it was very much perennial ryegrass as the species that we're wanting to focus on, although it does actually work for other perennial pasture species as well, such as cocksfoot or Phalaris or tall fescue, which would not be so relevant for your systems, but obviously perennial ryegrass is. So the key is to take those paddocks out of rotation, to close the gate before the ryegrass starts to develop a seed head. And there's it makes it quite easy in terms of what the cue is. It's not so much a calendar date, but just keeping an eye on what's happening to the grasses in the paddock and just looking to see when the ryegrass is starting to develop a seed head and then shutting the gate. And for us, that's October or mid-spring, but obviously that will be a different time for you. In terms of when to open the gate, the cue then is to make sure the seed's fallen. So walking through, looking at the seed heads and just that the seed's fallen. The obvious thing there is that the seed goes into the ground. If it's ryegrass, you'll get more seedlings. But later on as well, I'll tell you a little bit about what we're learning goes on inside the ryegrass plant that helps it in terms of regrowth after the end of the deferred period. So in terms of where we did the research and what we kind of did in our work on the deferred grazing, it was in particularly the upper North Island of New Zealand, and I'll show you a map in a moment, but you can see there on the left, the kind of country that we're talking about. Some of it was more gentle and rolling country, and then we had some steeper country that you could still get a tractor over, and then the picture there on the bottom left is quite steep. So that's 25, 30 degree slope, very much uncultivatable hill country. And you have lots of different species there. Agrostis, what we call brown top. Not so much Yorkshire fog there because it's too steep and dry. As in the middle picture, you could get quite a lot of Yorkshire fog there. So we looked at it in terms of split paddocks to see what happens when you scale it up, what kind of differences are you getting in terms of pasture growth. We looked at it in plots, so it's a little bit more controlled. On the right there, you can see glasshouse studies when we're trying to understand, well, how's the plant responding? What's going on inside the plant that's causing the changes that we're seeing at the plot and the paddock scale? Then we're able to use this information to model at a farm systems level what was happening. So for a map to show you where the farms were, top left there, you can see a picture of New Zealand. And there were 3 of the farms on which we worked, all in the upper North Island. I've just given you some information there on the farm sizes and the rainfall. So what we're referring to as summer wet and summer dry. So the ones on the right, the one on the top right with the plots here, we had quite a wet summer. So it was a really good test for a summer wet property. The same here on the bottom right, but this one, which we call summer dry, the annual rainfall wasn't too bad, but they had a really shocking drought. So right through from the end of summer into much of autumn, it was just very, very dry. And you can see that there in the picture. So on those sites, we compared several different grazing strategies. In particular today, we'll just focus on what we're just referring to as the graze treatment. And that just means it's rotationally grazed right through the year. In this case, you see a picture there of the field plot study. So basically in this case, the livestock were like mowers just to get to graze the grass. We were measuring what was happening with those pastures. And then deferred. So the deferred, again, the gate was shut so that the stock were excluded from grazing from mid-spring until the end of summer. So that's 12 to 16 weeks, depending on the property. That picture demonstrates quite well too in late spring what you'd be seeing here with the graze control, green and leafy, high quality. Then in the deferred, you can see it's starting to go to seed. Now I'll go on to some of the results, but high level first. What does it mean at a whole farm systems level? So we used Farmax. With Farmax, it's a model where you take the farm management data and the growth curve, like the current situation for the base model. then we, based on the kind of data that we were collecting from the experiments, we were able to develop a scenario where we could see what happened to the pasture growth when you deferred, and then develop that scenario within the model. So in this case, 15% of the grazable area was deferred. We found from the experimental data, and this showed up obviously in the model, that you get a pasture growth suppression during the deferred period in the deferred pastures. As you can imagine, as the seed's developing, the growth in those pastures is slowing down and it's suppressed. However, after the deferred period, you get a massive surge in growth. So if you look at the deferred pastures over a 12 to 18 month period, they produce the same amount as the pastures that were not deferred, what we're referring to as our graze treatment, but it changes the timing of the feed supply. So your pasture growth curve is different. In addition, in the paddocks that weren't deferred, you get much better control of those pastures. In other words, the feed supply and the livestock demand are much better matched. You don't tend to get paddocks going to seed and getting really stemmy. Instead, they're remaining green and leafy and vegetative. So this increases the nutritive value in those pastures. This is reflected by increased ewe and lamb performance, and we estimated for this particular farm that you increase the gross margins by 8%. Now, of course, it would depend on the year and on the farm and on the pasture type, but it was encouraging to see that there is that increase in profitability of the farm. So now just to some of the metrics within the deferred versus the grazed pastures. So I did mention the pasture growth curve. You can see here a graph representing that. So I'll just move my panel, it's over the graph so I can see it myself. Here we go. So you can see for one of the summer wet farms, you have the dashed line, which is the graze treatment, so no deferred grazing, and then the solid line, which is the deferred. So where this grey bar is here, you can see it's suppressed, that's during the deferred period, but after the deferred period, the growth rate increases. So, but after 12 months after, you've got the same amount of pasture being produced. And in terms of the benefits, it's twofold again. We've discussed how it improves the pasture quality in the rest of the farm, but also, as you've just seen, there is increased growth in the paddocks that deferred. So you do get a benefit for the deferred paddocks. Now you may be asking, why is this? We measured the perennial ryegrass tiller densities to see how they respond to the deferred treatment. The picture at the top right encapsulates quite well what the graphs are saying, and it's getting late for you, so sometimes a picture is quite useful. Basically, there was a large increase in the perennial ryegrass tiller densities. So just in case you're not familiar with the word tiller, we're just simply talking about, think of it as the grass stem. And there was increased tillering through new seedlings, remembering that the ryegrass was allowed to go to seed. But the thing that we didn't realise is how much new tillers from existing plants was so critical in terms of response that we were seeing. So on the left here, we have some grass for the summer wet property. So here for the deferred, this is the density of tillers and seedlings. You can see that it stayed quite high from the end of summer, so for us that's February, right through until the following year and June 19, so for us that's winter, and a lot higher here than the grazed. In the summer dry, you can see that the tiller density stayed higher, but then see how they've crashed? They've gone right down. So June 2020, the middle of summer, no difference between the deferred treatment and the graze treatment. So where do these tillers come from, and why have they crashed in the summer dry more rapidly than the summer wet? Now these bar graphs below explain this. The one on the left, so that's a summer wet, this little bit of white here is looking at the contribution of seedlings to the total tiller population. So you can see there weren't many seedlings. The increase in the total tiller population came mainly from more tillers from the existing plants. However, in the summer dry property, it was so dry, it was not good conditions from ryegrass. So the ryegrass plants really struggled. And the reseeding became very important in terms of the contribution to the total tiller population. So this is like a reseeding a pasture, an existing perennial pasture. And as you may be aware, it is difficult for seedlings to establish an existing pasture. There's a lot of competition and a lot of them die. And that's why when we look at this line graph here, you can see that the tiller density in the deferred rapidly declines. A lot of those seedlings died and the high tiller densities were not maintained for as long. Now, in terms of that's tillers, we looked at ground cover. And again, that picture just back in the previous slide, you could just see there was more ground cover, and this came out as well from the measurements of the plots and for the paddocks. The asterisks there just show when there was more ground cover, like significantly more ground cover in the deferred and the grazed, and that carried on for quite a number of months after. So that's quite important in New Zealand hill country pastures. If you're thinking about runoff and sediment loss and the impact on the water quality of streams and rivers and lakes. So we're quite interested to explore this further and just look at environmental benefits of deferred grazing. That's for another day. In terms of nutritive value, overall, in the longer term, there was not much impact on the pastures being deferred. At the end of the deferred period, it was definitely lower in the deferred pasture than in the one that had been rotationally grazed throughout the summer and was green and leafy. However, this depended on the site, because where we had the drought and it was very dry, it didn't matter if it was deferred or not. Remembering those pictures there, everything was looking dreadful and the pasture quality dipped down. And you can see that here at the end of the deferred period, we're looking at metabolizable energy values around about 8. It was terrible. However, in the dry property, it took a little bit longer to get to remove all that dead material and to bring the pastures back to an even kill. So that carried on into the winter following the deferred period, but not thereafter. In the summer wet property here with the graph on the left, because the rotationally grazed control pastures just stayed green over summer, and the deferred ones dipped because of all the production of seed head, much bigger difference here at the end of the deferred period. However, they rapidly recovered and were marginally better by the end of the autumn following the deferred period. So it's very farm dependent and climate dependent. But the encouraging thing is that with judicious grazing management and stocking appropriately, with especially for steep hillsides, the dead material can be removed and the subsequent pasture quality is good. We were particularly interested in what was the impact on the California thistle. So at Cirsium arvents, it's quite an issue for a lot of hill country properties, sheep and beef hill country properties, and dairy pastures as well in New Zealand. It was quite promising results from a paddock, and we've currently got a full-blown study now looking at what is happening to California thistles. We're looking above and below ground to see what's happening to the roots as well. And after the deferred period ended, so here on this graph, this is the end of the deferred period. This is the deferred section of the paddock, this solid green line again. You can see that thistle populations went a lot lower and they've stayed lower. This is, and you can see here in this picture, and this is carried on for a year or so after. So it's not so much that deferred grazing will get rid of the thistles, but we are hopeful that it may reduce the thistle abundance and therefore provide a useful management tool. So we're collecting data on this as we speak. Now for some of the mechanisms in the plant as to why we're seeing more tillering and more regrowth. And when you start to look at the energy reserves in the plant, it kind of all ties up. This is where a glasshouse experiment is particularly useful, because you can't easily go out and measure the root characteristics of the ryegrass or look at the carbohydrates. So you can see a picture here of tubes that are about 1 metre deep, in which we transplanted ryegrass plants and just mimicked the grazing regime. So they're either trimmed when there are 2.5, 3 new leaves, which is optimal in terms of rotational trimming, or else deferred, where we allow them to go to seed from the middle of spring until the end of summer, and then took them back into our simulated rotational grazing regime. So you can see pictures of the roots. Here's the stubs of the ryegrass plant, so the 3-inch tube. This is the root mass in the top third of the tube, in the middle section of the tube, and the bottom section of the tube. The same here on the right. So on the right, we have the root mass under the simulated deferred treatment. On the left, we have the root mass under the simulated graze treatment, where it wasn't deferred. Now we want to see what happens here in the paddock, but we were amazed at the increase in root mass. It was highly statistically significant, and that there are more roots at depth. We don't know for how long this lasts. We did do some work, and in the glass house, it carried on for a number of months after the treatment, but we can't extrapolate this to the paddock. We need to do some work in graze pastures, determine how it affects root mass at depth and for how long it lasts. But this does have implications for nutrient use efficiency, for water use efficiency. We've tried a little bit already to do this. There was a master's student. It was such a bad drought, she couldn't even get the core into the ground. So we'll continue on here. So in addition to the root mass and depth, there's massive implications for energy reserves. So on the right, you can just see the different parts of the ryegrass plant, where there's the leaves, the stubble, the crown, and the roots. What we found in this glasshouse study was that when we were simulating the deferred period, there was a massive buildup of water-soluble carbohydrate in all parts of the plant. And the asterisks there indicate how statistically significant it was. But the main thing there is in the leaves, we had twice as much water-soluble carbohydrate in the leaves, 3 times as much in the stubble, 5 times as much in the crown, and twice as much in the roots. So this was at the end of the simulated deferred period. So if you think of this, a massive amount of energy that's sitting there, then you come along out in the paddock and you graze off that dead material that's gone to seed. You're exposing the base of the plants to light. You have tiller buds that are sitting there. It's autumn. You've got lower soil surface temperatures. You've got the rain coming. You have conditions ripe for ryegrass growth, and it's on steroids. It has greater water-soluble carbohydrate content. It's got the energy reserve, so it goes for it. So no wonder you get the increased tillering. No wonder you get that increased regrowth. And then that regrowth is what enables the increased pasture growth rates, and it rapidly catches up to the graze treatment, so that you're not penalised in the longer term by the suppression in growth during the deferred period. For the farmers, it was also very useful drought feed. As farmers this year, we've had quite severe droughts where they've been a lot more relaxed at the end of summer, because they've been able to open up the gate to paddocks where they have that standing accumulated dry matter there. It's not going to be as high quality as if it's green and leafy, but it's feed. And it's meaning that they're not having to reduce stock numbers as they would have otherwise, or to bring in imported feed. And as well, they're getting the benefit for the rest of the farm. So now it's over to questions, but that's some pictures there of the farmers on the right. And it's been a great program of work. There's been very good industry support and support from other science research institutes and regional councils. So thanks.
Thank you so much, Catherine. That's brilliant. It's certainly relevant to the sort of questions that we're asking ourselves at the moment as we investigate the application of mob grazing to the UK. So it's a similar but a longer term form, I guess, of deferred grazing. We've got a whole load of questions for you, and I'm just going to fire them away before we open up a bit more. Ragwort, is that a problem in New Zealand? I can't remember.
Yes, yes, it can be. Not so much in the farms we're working, but on other properties, particularly in the South Island, yes.
Yeah, and do you think it'll have a similar impact on ragwort as it did with the Californian thistle?
It wouldn't surprise me. I'd like to kind of do it and get some data before saying anything with certainty. But we have had statistically significant results on broadleaf weed content. Deferred grazing has reduced broadleaf weed content because, and in terms of why, the competition I think would be the most obvious possibility. You're having possibly 4 tons of standing dry matter there at the end of the deferred period. There's a lot of competition, a lot of shading. And I think the competition below ground is also very important and can help to suppress some of those broadleaf species.
Of course, yeah. On the note of thistles then, are they meant to indicate a potassium imbalance? So do you have any metrics of the nutrient changes potentially as another theory for the results?
We looked at the soil nutrients. I don't have the data here, but I can't remember there being any imbalance in the nutrients. The farmers that we're working with were putting on and were doing annual soil tests and ensuring that any nutrient deficiencies were corrected. So I think in this case it would be unlikely to be a calcium imbalance. Good
potassium as well.
Oh, sorry, potassium.
What did you think the cumulative ME per hectare would have looked like, grazing versus deferred? That's a tricky one.
Yeah. Overall, it will be better when deferred grazing is used in the system, because if you're deferring 15% of the farm and you are having, 85% that's not, and you're improving the quality on the rest of, like all those other paddocks, overall you will be having a greater ME at a whole farm scale in a deferred system. And it's for that reason, in combination, for that reason that we're able to get the greater livestock production. Does that make sense?
Yeah, absolutely. We talked about this, didn't we? How you need to think about the whole system, how you're improving quality in one area, get good animal performance in your main rotation, plus you've got the benefits of the deferred grazing later on. Yeah, absolutely.
So I think for a lot of farmers, they see the deferred paddocks and think, oh, this is terrible quality, and it looks terrible, and it does. And the farmers that we're working with are saying, don't get put off by that. Think of the whole farm. Think of the improvement to pasture quality and ME at the whole farm scale, as well as the rejuvenation that you will be getting in the paddocks that are deferred.
Fantastic, thank you. Yeah, a lot of people are probably being fascinated by the root mass differences. That photo is quite striking. And do you think that will translate into better carbon sequestration?
We'd love to find that out, because that's a question we're asking as well, and especially if you get more roots at depth.
Absolutely. And then how important do you think the timing of the first graze after deferring is? So can you leave it too long and lose that carbon in the ground?
Yes, that is so important. That's real. Thank you for bringing that up. When we are thinking of almost as a pasture renovation, pasture renewal, pasture rejuvenation, we suggest to farmers that they graze off in a New Zealand context before the autumn rains. It's really important for the light to get into the base of the plants to stimulate the new chiller development. So if it's left too long and you have a rank vegetation going right into late autumn, for example, the new tillers aren't going to get a chance to grow. However, we do know of work that's been done where they have intentionally done that to thin out the pastures, to weaken the grass, and therefore to allow the clover to come through. And in that case, it's actually helped with increase the white clover content for several years following. A caveat, you've got to be really aware of the other pasture species you're working with. For example, a agrostis with a brown top, that can form quite a mat, and it can be difficult to get rid of that dead mat of grass on the ground. So for those that would think of using deferred grazing to increase white clover, yeah, just to be wary if there is, if it's dominated by species such as brown top.
Fantastic, thank you. Yeah, that's a very good point. And I just, well, a few of these questions are actually quite similar, but I like the idea, and Graham has asked this question, is whether you see the deferred grazing as part of the rotation over the whole farm. Do you see the opportunity to alternate between blocks of land to have this rotational grazing benefit?
The farmers that we're working with have found that if they defer different parts of the farm each year, like on a rotation as such, they can spread the benefit across the farm. They're very mindful about which paddocks they defer, in terms of they wouldn't want to defer paddocks that stock regularly uses corridors to pass through. So there's the practical kind of things they need to consider. But they'll also look at their pastures and think, oh, this one's starting to, what they would call run out, in terms of the ryegrass populations starting to struggle a bit. And I think, well, let's defer this one because it can boost the ryegrass plant numbers and tiller numbers. In Australia, I have known them to defer some paddocks for a few summers running to increase the desirable species content.
Great. That's fascinating, thank you. And then as a couple of questions on this line is, how low are you grazing the deferred, how low do you advocate grazing the deferred grazing area down to? Is it important to get really low in the first graze?
Often the first graze will still be looking a bit messy. So let's say it's 3-4 tons of dry matter. It might only come down to say 1,500. Cattle would often be better to bring the covers down, but we had one farmer who did it with a mob of sheep. So it's possible with sheep. By the second graze, we'd be getting it down to say 1,200-1,300 for these beef and sheep hill country pastures.
Fantastic. Well, thank you very much for that. I really appreciate it. I'm just going to invite just our other speakers of the evening. I just have a couple of questions for our last sort of 10-15 minutes, just bringing all the research together that you've done. So if I can invite you all back, Claire, Aurelie, Sarah, Malcolm, that would be great. Thank you. I think a key theme of some of the rotational grazing work is to try and balance the live weight per head difference and the live weight per hectare. And I think, Sarah, you touched on it a lot on your slides, and Aurelie, and I just wondered, raise your hand if you want to answer first. If anyone would like to comment on that fact, the balance between per head performance and per hectare performance. I mean, obviously they relate. Can I hand to you, Sarah, as soon as you mentioned it in your slides?
Go on then. So the sort of reason, or the supposed reason for the difference is with the rotational grazing, you're sort of forcing those animals to eat the stuff that they wouldn't really go for. So you're kind of limiting their individual intake in a way, because you're trying to force them to clear off the not preferential stuff that they would eat. In terms of moving forward, I know we're sort of starting to see sort of the divergence in terms of output per hectare and per animal. And my interest would be, if we could sort of continue with the trial, is how, after the set stocking paddocks have been preferentially grazed and they've grazed out the nicer stuff, will that then show through in terms of the individual live weight gain further down the line, once the pasture sort of gets a bit messy? It's annoying at the moment that I haven't got the full data set for the pasture quality data. It's just been delayed by COVID, and just hoping to get it soon. But yeah, that would be my take on it, is what would happen in the long term in terms of the set stocking versus the rotational.
Yeah, I mean, it looked like you mentioned that the set stocking, they weren't allowed to go below 2000, so it looked like it was managed relatively well, perhaps compared to maybe your average farmer. I don't know, I wouldn't like to say, but it looked well managed.
Yeah, so we're not sort of allowing them, I guess, to overgraze too much of the field, because we've got that minimum threshold. I would like to, we're looking into possibly getting some GPS sensors and some other sensors to put on the animals, just to see the areas of the fields that they're preferentially grazing. It's kind of a bit of a balancing act of sort of learning to sort of improve the systems as we go, but also I'll see some sort of differences between the system, but then trying to capture that in a sort of scientific context. And it's like, well, visually they look different, and it looks like the cell grazing is growing more grass, but then I have to sort of get the data to back that up. So it's quite interesting.
And Aurelie, you're nodding your head, and it must have been quite surprising results of the 4 versus 8 paddocks, because like you say, the 8 paddocks grew more grass, but where did that additional grass go?
Mm-hmm. Well, it's just it's all to do with the way we designed it. We were able to to quantify that extra grass and use it not for that batch of animals, so either to grow some, to feed an extra batch of dry animals or to produce silage. So in that sense, when you express things on a per hectare basis, it's quite useful when you look at the overall system and you try, more and more we try and produce more sustainably. And so, looking at that is useful. But I think in the same way, when you're expressing things per head and at the animal level, it's also important to make sure you capture that so that you don't push the system maybe too far. And, you use, these other metrics to try and maybe impose limit on how far you should push the system and make sure the animals are not left out as such. So I think it's just, you can't necessarily choose one or the other. And I think scientifically, it's a bit difficult to design. A single project won't be able to provide all the answers. So with a multiple series of things, we'll understand better how these behave. But yeah, the risk is that you push something too far and then you lose too much in another part. So, but that's what makes it interesting. So keeps our brains active.
Yeah, well, that's your challenge. I mean, all of you are systems researchers, aren't you? And there's so many things that you have to. I mean, I was amazed, at the presentations. You're going from, animal behavior, meat quality. You're looking at the root mass. You're looking at the animal performance. There's so much you're having to piece together. And I was just wondering, on that note, what sort of challenges do you find? Catherine, you showed pictures of the deferred grazing sort of strips, which probably wouldn't happen in reality. How do you find it so challenging to have a controlled systems experiment, but still maintaining that representation that can be transferred to farmer level, to the farm?
Having the range of plot studies, so strips there, as well as having paddock studies was really helpful to enable us to extrapolate what would happen in real life. So the paddocks were a few hectares each, and half would be deferred and half wouldn't. For that one particular study, we involved 3 farms and a few paddocks in each farm, and split the paddocks. So that kind of approach is really useful to get meaningful real life data, and the farmers are actually involved in collecting that, which was great. Does that answer what you're asking, Poppy?
Yeah, I mean, I could see in that example, it was a really nice, a nice balance of the two. Yeah, it was just other examples, I mean, where you've been challenged to try and replicate something experimentally or robustly, which is still relevant to the farm. I don't know if anyone else.
We've done other studies on farms where it has definitely been challenging. For example, on working with commercial farmers where there's been a change in farm ownership, and the new farmer has perceived the importance of the research quite differently. So we'll put a grazing break right across the middle of the trial plots. But we're so grateful for being able to work with the commercial farmers. We learn so much from them.
Yeah, I bet. Would anybody else like to comment on that, on the challenges with that? Because obviously it's something we need more of, systems research. I'm a big advocate of it, but it's obviously really challenging. Claire, sorry, you've got your hand raised. Yeah.
Yeah, sorry. I would say it is very challenging work at a system level because it will never be a plot. You know, it would never be as precise as you could. But for example of our research farm at Kirkton, we're lucky to have that estate. I mean, it's 2,200 hectares, and we've got 2 glens, 2 valleys. So very often we've done experiments in the past where we use one glen versus the other, so where the control versus the place where we did the change. And I suppose that's as best as we can do. Or we've got the flock, 600 ewes, and we split the management in 2 different ways. So it becomes very challenging, especially for the technician who has to remember which system does that ewe belongs to, etc. But I think in the long run, I think it gives more of a overall views, and I suppose for farmer it allows them to maybe see the whole thing and not just one particular component of that whole system. So it might not be very precise, but at least it's more comprehensive in a sense, I suppose.
Yeah, no, I see, and I see the amount of data you have to collect in order to manage those systems. Sarah.
Yeah, I kind of agree with the sort of challenges of trying to be a sort of robust, controlled science experiment, but also trying to mirror what would happen in the real life situation, and having to do sort of the whole system analysis. There's sort of a lot of data, as you've seen, that can be collected, and it's balancing that scale, and the bigger the scale, the more sort of resources and people you need to be able to collect all that data, versus, you know, if you're going at a bigger scale, you're kind of introducing more variability in terms of sort of topography and, you know, just differences between fields and stuff. So it's a challenge sort of more widely at Northwick. So we've got the Northwick Farm Platform, which is trying to do sort of mini farm level research, and so we've got mini farmlets that have got 4 or 5 different fields each, and yeah, it's just trying to be sort of as consistent and reduce the variables as much as possible, but also measure as many of the variables and how they're changing.
Yeah, just means you have a lot more work to do, I guess. Thank you. There is a lot more on, I'm just sorry, I'm just going to ask one more question and then I will call it a day. I realise we're a little bit over time, but there's a lot more work and required, I guess, on the carbon sequestration side. And I know a lot of you are doing sort of greenhouse gas type work as well. And I just wondered whether, yeah, you'd like to comment on what else is needed in terms of grazing management and the offsetting of greenhouse gas emissions through carbon sequestration. I don't know who would like to answer that or comment on that, probably that very vague question. Aurélie.
Yeah, maybe briefly, it's something we're really looking into at the moment. So, I mean, there's a number of things you can do, both, you know, at the animal level and the grass level together. So we're looking into, you know, changing the diversity of the swards. It would probably link to, you know, the root system as well, and how early and how late you can use them in the season to minimize the time that the animals need to be inside where they emit more. So yeah, the diversity of the grass sward, trying to select animals that are more efficient or less emitting less. And then also there's the aspect of the history and the management of the land itself, you know, how heavy you put fertilizer on, and if you stock it heavily, there'll be, you know, more slurry and that as well, and that would also affect the carbon sequestration potential in the soil. So I think there's quite a lot going on at the moment. So I think it's just, you know, I think we're very soon in the next, you know, few years, if not that, we'll know more from a number of places, you know, across Europe and elsewhere. So
yeah. And one of the audience members have asked about water infiltration rates between the different systems. Has anybody investigated that? And resilience of pasture for outwintering? I'm guessing he means in terms of poaching damage through the winter. Has water infiltration been a thing amongst any knowledge there? Sarah, thank you.
I haven't done it directly on the experiment that I'm running, but there's the soil carbon project that's being run by Dutchy. They've been looking at some water infiltration on rotationally grazed farms versus not, and the data they're collecting is suggesting that the infiltration is better on the rotational grazing farms, but again, it's very preliminary data at this stage.
Yeah.
It's something that we'd look into. Anecdotally, it seems that the set stocked paddocks, I'm more confident in driving on them than the cell grazing ones in the winter. And bearing in mind we're on very heavy clay soil, so it gets wet, very wet. So I would like to sort of at some point do a measurement of that to see what is happening, whether the infiltration is better and thus the cell grazing has a higher water holding capacity.
Yeah, because that could be key to you know, increasing the time that animals are out at pasture and over the winter, couldn't it?
Yeah, I think one of the learning curves is the whole perception of sort of poached land. So kind of in a way been in a sort of training the research farm staff to be okay when there's a cell that looks pretty badly poached, but I have to explain it's going to have a 30-day or 40-day rest. By the time they come back, it will have recovered. So I think in terms of the stuff we've been talking about this evening, some of it doesn't actually look pretty. I mean, you know, the photos that Catherine shared in terms of the deferred grazing, it doesn't look great, but if it, you know, in terms of the whole farm system benefits overall, then, you know.
Yeah. Catherine, could I bring you in then? I see you've put through the deferred grazing booklet in the chat. Thank you very much for that. That'd be great. On the deferred grazing side, do you have any inclination in terms of, I mean, were any of the farms like prone to being poached in the winter? They seemed quite dry farms, didn't they, I guess?
One of the summer wet farms had struggled with some poaching. Now, we haven't done any work on it, but based on the farmer's experience, he found that deferring seemed to help in terms of recovery from what we call pugging poaching. There's a lot of organic, there's a lot of decay of the plant material. There was some evidence of increased earthworm activity in the short term, but not the longer term. Going back to the question about water infiltration, so this isn't comparing set stock to deferred, but to rotationally grazed, but deferred to rotationally grazed. It was getting towards a hint of better water infiltration and some improvements in soil structure. For that part of the work, we didn't have a lot of statistical power. I think basically if we'd had more statistical power, more plots, more paddocks, it would have been there, and possibly we need to defer for a longer period of time. But yes to poaching, we think there could be some benefits there, and also earlier on to the water infiltration.
Yeah. Okay, it is nearing 9:10, and I just want to say thank you all so much for delivering so much content. I think we could continue this chat on for probably another hour, but probably shouldn't, or we'll lose more people. Yeah, you've all been excellent and really given us a great overview of the important issues, and really made me feel exhausted with the amount of data you're all collecting and having to bring together to deliver meaningful results for us all. And I really have a lot of respect for that. So yeah, thank you very much. I'm just going to draw this evening to a close, and tomorrow night you're all welcome to join us, and we're going to have an informal grazing chat, so same time, 7 till 9 tomorrow night. Join myself with colleagues Lorna Galloway and Jack Munro to just geek out that bit more about grazing. So I hope to see some of you there. So thank you very much all, and good night. Thank you, or good day to Catherine. Thank you.
Thanks. Thank you.